Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is Lesson 8-9 for Course 3, Exploring Similar Solids. Our objectives are to use proportions to find missing measurements of similar solids, including surface area and volume. Our key concepts are if the ratio of corresponding dimensions of similar solids is A to B, then the ratio of their surface areas is A squared to B squared. Area is in square units, so think about squaring and squaring. The ratio of their volumes is A cubed to B cubed. You're going to cube each of those because volume is in cubic units. So a nice way to help remember those. All right, definition of similar solids are solids that have the same shape and their corresponding dimensions are proportional. Okay, so cubes of different sizes basically would be similar solids. Various balls of different sizes would be similar solids, and so on. Balls, again, being spheres. All right, let's look at a couple of samples here. At an ice cream shop, the small and large cones are similar. The small cone has a radius of 3 centimeters and a height of 12 centimeters. The large cone has a radius of 5 centimeters. What is the height of the large ice cream cone? Let h equal the height of the large cone. Use corresponding parts to write a proportion. Okay, so basically since they have h on the top, we know that we're going height over radius. So the height of the large cone, is missing, but its radius, I started off on another tangent, and that's not the way they've done this. The dimensions of the large cone are a height of 5, a height of unknown, and a radius of 5. So I'm going to put the radius here because these are using the dimensions of the large cone. The height of the small cone is 12 centimeters, and its radius is 3. Okay, I would have probably myself done that a little bit differently, which is why I started my explanation, even though I had it written down. We can talk about that in class, how there are different ways to do this. But this is probably the best way to do it because then you're doing the ratio of large to small. So that makes sense. Anyway. So I'm going to multiply each side by 12, or basically solve the proportion if you want to think about it that way. They've just done multiplying by 12 because 12 is the least common multiple for 12 and 3. So these will cancel out and I get h, and then I get 5 times 12 is 60. 3 times 1 is 3, so 60 over 3 simplifies to 20. So the height of the large cone is 20 centimeters. So again, dimensions, this is large height, small height. Large radius, small radius. So I'm going large to small, large to small. Okay. There is an example for you to complete. And we have one more example on the back, surface area and volume of similar solids. Okay, this has many parts. Well, it looks like it's really hard, but I don't think it's going to be that bad. All right, a square pyramid has a surface area of 39 square centimeters and a volume of 12 cubic centimeters. The pyramid is similar to a larger pyramid, but its side length is 2/3 that of the larger pyramid. Find the surface area and volume of the larger pyramid. Okay, so here we go. The ratio of the side lengths is 2/3. So the ratio of surface area is going to be 2 squared over 3 squared, or 4/9. Okay, so here we're looking at surface area. So we're squaring the ratio that we know by which they're similar. Okay, so we're going to, the surface area of the small pyramid is 39. The surface area of the large pyramid is missing. Okay, so we'll use capital S for surface area. I'm going to carry that over here. Surface area equals, my proportion, is 39 over S equals 4/9. And I'm going to go from there. All right, so 339 times 9 is equal to S times 4. So then you're going to divide each of these by 4, so 39 times 9. And then you're going to divide by 4, and you're going to get 87.75. So the surface area of the large pyramid is 87.75 square centimeters. It didn't ask us to round on this one, so we won't. Okay. Now, let's look at the volumes. If the ratio of the side lengths is 2 to 3, the ratio of the volumes is 2 cubed, or 8, over 3 cubed, which is 27. So the volume of the small pyramid is 12. The volume of the large pyramid is missing, so we'll fill that in with the V. We can substitute in then 12 over V should equal 8 over 27. And then write our cross products. 12 times 27, V times 8. You're going to divide then by 8. And let me do 12 times 27 so we have a check number. That's 324 divided by 8 is 40.5. So the volume of the large pyramid is 40.5 cubic centimeters. Now if I wanted to round to the nearest whole, that would be 41 cubic centimeters. And here, if I wanted to, I could also round this to 88 square centimeters, just depending on whether or not you're wanting to round. It didn't specifically say here. Generally, if it doesn't say, I don't round, or I usually don't give the whole number. I usually give a little bit more than, 1 or 2 extra places. I will go with reasonable, though. Okay, if there are no specific directions. All right, so try the 2 quick checks, come back, and we'll discuss.